This is Unit 2, Section 2.3, Rationalizing the Denominator. So we've spent our previous sections looking at simplifying single radicals, or ones with a coefficient out in front. Then we did multiplying and dividing the radicals. This is going to be looking at a special case of dividing radicals. And so this is going to be a process called rationalizing the denominator. And it happens when we have a radical that's left in the bottom that can't be simplified further. Radical 2 is as far as I can simplify, but it's not considered as far simplified because it has a radical in the bottom. So even though the radical itself is simplified, the overall expression is not considered simplified with a radical in the denominator. So we're going to go through this process called rationalizing. There are a couple things that we need to make sure that we are remembering from our prior knowledge. That when I take something times itself, I get the square root of 5 squared, which simplifies just to 5. Same thing here, square root of 7 times itself is the square root of 7 squared. Square root and squaring is an inverse operation, so it cancels it out. So notice that if I had something that started with a radical and I multiplied it times itself, it ends with no radical. So if I had the square root of a, b, c, d, e, if I multiplied it by itself, a, b, c, d, e, because I'm taking it times itself, that means I have those two groups at a square root once, it would cancel and I'd be left with just A, B, C, D, E. The other piece of information that we need to recall is that anything divided by itself is 1. So if I took 3 times 1, it doesn't change anything. If I took 3 times 11 over 11, it still doesn't change anything because this is really the equivalent of 1. But what it does allow me to do is if I wanted to, I could rewrite that as 33 over 11, which is another way of writing this 3 altogether. So we're going to be using a couple different methods here to rationalize the denominator, or a couple different prior knowledge pieces. Knowing that if I square something, it cancels the radical, and if I divide by the same number, it's always 1. So our process here, it says this is still dividing by a radical, but when a radical remains in the denominator, it's not simplified. So the process we're going to do is we're going to take something times itself, radical b, because this will clear the denominator. It'll clear that radical in the denominator. However, I can't just arbitrarily pick multiply by radical b because that changes the whole quantity. What I can do is multiply by radical b divided by itself. Now this is 1. So I'm taking a over radical b times 1. So this will not change the quantity and it still gets the rationalized denominator here. So if I take radical b times itself, I get b. It breaks out of the radical. On top, I still have a, and I still have radical b. This is what I would get for simplified. This process is called rationalizing the denominator. To be fully simplified, it means there's no radical left in the denominator. Sometimes this can occur with dividing, like we did the other day. The process of eliminating the radical is called rationalizing the denominator. To rationalize the denominator, we multiply both the top and the bottom, numerator and denominator, by the radical in the denominator. Then simplify. Okay, so this is still going to build on what we've been doing on the prior days here. We have 1 divided by radical 2, and it's not rational, or it's not simplified because of the radical in the bottom. To rationalize, we're going to multiply both the numerator and the denominator by the radical in the denominator. So our radical in the denominator is radical 2. and I multiply across. 1 times radical 2 is radical 2. Radical 2 times itself clears the radical to give me 2. I can't simplify that further, so there's my answer. On number 2, I have 2 divided by radical 3. I can't leave a radical in the denominator, so I'm going to multiply both the top and the bottom by that radical 3. Multiply across, I can't combine 2 radical 3, and on bottom that clears the radical. I check, 2 divided by 3 can't simplify, so then I'm simplified. On number 3, I have 4 divided by 3 radical 5, can't leave a radical in the denominator, so I rationalize, multiplying both the top and the bottom by that radical. And notice I'm not bringing the 3, I'm just focused on fixing the radical. So 4 times radical 5 doesn't simplify. And on bottom I have 3 times radical times itself will simplify coming out. And I have 4 radical 5 on top. Can't combine that any further, but I can multiply 3 times 5 to get 15. I check, 4 divided by 15 doesn't simplify further, so that's my final answer. Okay, on number 4, we have a radical 3 in the bottom here. So I take radical 3 on top, radical 3 on bottom, and multiply across. 3 times radical 3 doesn't combine, but a radical 3 times itself simplifies. I check, 3 divided by 3 can cancel out, leaving me just with radical 3. On number 5, I have 2 divided by radical 2 divided by radical 3, but those don't simplify. So I rationalize, multiplying by the denominator for both numerator here and denominator. So I get 12 radical, 2 times 3 I can combine. And on bottom, radical 3 times itself clears the radical, inverse operation. I check, 12 divided by 3, I can simplify. That's 4, and the radical 6 comes down. And on our last one, okay, we have negative 4 times square root of 5 divided by radical 2. Multiply both the top and bottom by radical 2. So now I get negative 4. I can combine our radicals, positive 10, 5 times 2. And on the bottom, radical times a radical clears the radical. And last step is to check here. Negative 4 divided by 2, negative 2, and the 10 comes down. All right, so rationalizing the denominator is telling us that we need to make sure we're recognizing we cannot leave a radical in the denominator. It's not simplified. So to do that, we have that process called rationalizing the denominator, which gives us sometimes a fraction, but that's okay, because in the end now, our answers, okay, here doesn't have one, here doesn't have one, but our answers here no longer have a radical in the denominator. And that's our goal for simplifying. Okay, let me know if you have questions on your homework, and I hope you have a good day.